Average SAT taker doesn't really have a method of figuring out how they're going to solve SAT math problems. They don't really understand that it's more about the skill of solving the problem versus focusing on memorizing a method that's going to generally apply to every problem, right? A 1600 score might have originally thought that, but through practice and through understanding what actually helped them solve complex problems, they realized that it wasn't actually about the method, but it was about the skill of solving the problem. It was about applying certain things that are generally applicable to every problem, and that's how they got the score that they got. So I used to be pretty terrible at complicated math problems, and it wasn't until I was forced to practice them very early on, almost freshman year to sophomore year, by my parents actually, where I was forced to do these problems again and again and understand that there's an underlying method between complicated problems in math that don't just involve the application of one type of skill, like understanding zeros of a quadratic, let's say, but actually applying furthermore with like how to find those and where do they pop up and why do they exist, right? So it was understanding those things that really helped me get good at complicated math problems. I was forced to practice them, and while practicing them, I noticed certain trends that are the case for most of these problems, and that's what I'm going to share with you today. So these are SAT math tips, and this is how you can get a perfect score. All right. So first I'm going to go over some obvious stuff. And if you're scoring already above like 720, 730 points in the math section, this section is going to be useless for you. So just skip to the next one. All right. So some obvious stuff. Math is all about the skills of the questions, right? There's no rote application again and again that's going to help you get good like the reading section. That's not the case. There are very specific skills that you need to have learned in school or online, or you're never going to get that question correct. And you need to figure that out based on taking practice tests. You take the practice tests, figure out what you get wrong from them, and then based on those, figure out what skills are actually applicable in those practice problems, and then learn them separately if you just don't know how to encounter the problem, right? If you don't know how to encounter the problem, and chances are you probably haven't learned it in school if you don't know how to encounter the problem, you need to go online. Khan Academy has a bunch of problem types, video examples, difficult video examples, and step-by-step generated problems that give you hints if you need them, and it's all for free. So I highly recommend this if you're under the 700 point range, because that means there are still some conceptual ideas in math that you don't understand. So problems that you see and then you just get wrong, like you might think you know them, but you get them wrong because you don't know the correct method to apply. So figure out the methods and figure out exactly how to solve the problem, because you shouldn't be guessing at all. If you're guessing whatsoever, that means you don't understand the method, and use this framework to figure out the thing that you don't know and practice that thing. All right. So this is the harder part, right? Getting to the 800, getting to the perfect score, you need to apply certain skills that are generally the case of these more difficult problems that are often getting wrong after you've reached the point of, understanding every single skill, right? And the first thing is problem analysis. Word problems in SAT math are very difficult to approach, right? And the reason is because they often contain a lot of junk language. And even if it does contain all the essential language, picking apart the actual useful information from that and turning it into math or into a formula that you can apply a method to and solve is the most difficult part. So you need to train your skill of that. So how do we do this? Figure out a method to isolate the math parts of the problem. And the way I do it is I read through the problem and I isolate the specific speech, like whether that's add, subtract. Obviously it's not going to be that simple, or if it's compare or understand this is greater than, less than. Figure out all of those words, right, that can be translated into literal math, and then highlight them as a part of your problem. The rest of the problem, you just don't need to actually acknowledge, just the math portions, right? And see if you can create formulas just based off of the math that they give you. And if you can do that, then you have a formula that you can instantly apply an equation or a method that you've previously learned to it, right? So that's the most difficult part of problem analysis, is just getting into the habit of isolating the math portion and just getting straight to the answer, because you might get lost completely reading the word problem, and you shouldn't be doing that. You should just focus on instantly isolating the math portion. And the only way you get better at that is just practicing doing that on word problems in the SAT. You're not going to get better at it just thinking of this method. You actually have to apply it again and again and get good at isolating. And that's when this method becomes something that's going to get you a higher score. All right. The singular constant per equation, right? So for just this is just a mathematical concept. For an equation to be solvable, it needs to include one variable per the equation, right? If you have a series of equations, right, a systems of equations, two variables can be there, but you need more than one equation because you can't solve something if it just has two variables and one equation. There's no way you can figure out a direct answer that's always going to be the case for both the variables, right? And why this is particularly useful is because in SAT math, you're going to encounter these problems that are going to specifically mention like two different kinds of variables, right? And you're going to think that they're independent, that they're X and Y, when in reality, they might be X and 2X or X and X plus 10, right? And those are obviously just general examples. But what I'm basically trying to get at here is every time you have two variables but only one equation, you're going to encounter this like problem where you can't solve them. And that's because it's not really two equations. Obviously, everything on the SAT section is solvable and has a clear, direct answer, unless, the equation is not solvable. And one of the answer choices is that it's not solvable as a result of having two variables. But to figure out if this is actually the case, you need to see if there's connections between the two variables. Are there relationships between the two variables described in the words itself or within a mathematical equation that you can use to apply instantly, right? And if that's the case, then you don't have two variables, you actually have one, right? And it's just the other thing that is represented by the variable is just a modification of the first variable, right? So use that information to realize that multiple variable questions, they just don't exist, right? And you're always going to be able to solve it, unless it's a systems of equations, which is the only main exception here. You're going to be able to solve these problems that you think have two variables because that's not really the case. So you need to get into the habit of figuring out what the relationship between variables are. And that's the most important skill. Similar to the last concept, you need to practice this, and just knowing it isn't going to help you. All right. Complex applications, right? So every problem, right, has almost a simple version where you just have to know the method, right? Like you just have to know like what the slope is in a slope intercept form, and then you can get the answer. But one of the questions might ask you, what does the slope have to be in order to fit these 2 points? Do you know how to do that, right? And that might be a pretty simple example that you might understand how to do. But how do you combat these more complex like examples of harder question types, like turning a regular formula into a circle equation with completing the square? How do you do that? So there are three main ways to combat this idea, right? One, you have to master the skill of the problem to itself to a high extent, right? And this means like if I have a certain formula, I know what every single individual point means, how it would manipulate the graph, and like how I would make certain points fit on the scale or how I would convert it to different types of equations, right? I need to understand the ins and outs of every part of the equation and why it works, right? Knowing every portion of the equation and of the concept is more important than just memorizing the basic formula and location of how to solve it, right? So memorizing how to solve the problem would just be like knowing that the number is the slope in a certain type of equation. But if you were given a different type of equation, you wouldn't know how to do it because the number isn't just given to you. Knowing every portion would be able to turn that form into something else, graphing it so that you know the slope, or being able to solve the slope by graphing it on the piece of paper and physically finding the slope based on the rise over run, right? So knowing every single portion is how ultimately like the best way for complex applications, but there are like slightly easier ways that aren't as comprehensive, such as going through that specific application before, like seeing it beforehand and understanding like, okay, I've seen this beforehand and this is how I do it. So it might be a complex application, but you've seen it beforehand. So you know exactly the memorized solution to do so, right? What you have to do. But this isn't going to be the ultimate fix. The ultimate fix is going to be the first skill of mastering the problem itself, right? And third, understanding how other methods and problem types apply, right? And this is problem awareness. Understanding how other methods, right, combine with your problem type to be able to be solved, right? For example, the example that they gave previously of a circle equation, but you have to use completing the square to fully understand how it works, right? So completing the square has to be used in order to turn a circle equation into that h minus k format, right? Where you have the squared of both sides and you have the x and the y on one side and it equals the radius. You might have to complete the square in order to get those factored squared like parenthesis functions out in the circle equation, right? So basically it's if you have a mastery of the different kind of skill and you understand how that can be applied with your own method, that's how you're going to be able to solve bigger problems. And how you get that skill is just problem awareness, right? Just understanding that that method has to be used in different kinds of scenarios. And that just comes with practice. Ultimately, you're not going to be able to get all of them right on your first try. You have to practice the problem types. And the SAT is very predictable, so it makes it really easy to do this. All right, some final tips. This is a guiding phrase that I just came up with that I think will really help you. And it's the lack of accuracy that you have in your problems is directly related to your lack of understanding in the problem, right? And I want you to use that sentence as a guide to your practice, that there is no like quick fix. There is no skill you can instantly apply, but there are things that you can do with certain skills. And if you repeatedly practice them, right, you increase your understanding of the problem. Your accuracy is also going to increase. Don't fall for this lie that there's some like hidden trick that you can apply that's going to instantly boost your score, right? That's not the case. It's using those tricks, but also practicing them repeatedly and getting yourself more familiar with the problem so that increases your understanding and increases your accuracy. Unless you physically don't know the skill, like you don't know what quadratics are, right? Understanding what quadratics are is going to instantly improve your score, right? But if you're at the point, 700 plus on the math section, your lack of accuracy is directly related to lack of understanding and familiarity with problem types. Focus on your weak points, the problems that you get wrong most often, and you're going to excel. Thank you guys so much, and I hope you learned something today.